Hello everyone, my name is Guy and welcome to Platformers TV, the weekly live stream of the Platformers community. And today we are going to talk about a really interesting and deep topic, which is scaling Kubernetes networks. Scaling Kubernetes networks can be hard, can be interesting, and I'm so glad that my friend Mey Beisaron was able to join today. Hey May, how are you?
I'm so happy and excited at the same time.
It's all great to hear that, and I know that you have a really great presentation and story to share with everyone that joining us today. So I'm really excited about that.
I mean, it's real life. So like I hate it when I call it like the story of what happened because it's a real life thing. But okay, we'll we'll dive into that and all of the feelings that I had when I worked on the thing that I am going to talk about. They're going to come back up. So if there will be a little bit of drama here,
Yeah.
prepare.
So if what is great is that we love a lot of drama, and if there are like people in the audience that you want to comment, ask questions, feel free to comment. If you are on LinkedIn, you can just comment on the post. If you're on YouTube, you can comment on the video, and based on that, we will answer your questions here live. This is the great thing about going live.
Definitely.
Um, cool. Do you want to start?
Yeah, I think now is a wonderful time to start. And yeah, now my screen is shared and I can dive into Kubernetes networking at scale. Oh my God. I don't want to start talking about that. I want to start telling you, everyone here, about something that happened. So, I want to tell you about a specific time, a specific date. It was February 25th at 4 p.m. And that was about 7 hours before my flight took off to Milan. I love Milan. And just at that time, right, 7 hours before my flight, that's when I decided to deploy a feature I've been working on that changes base a lot of network configurations in our production EKS cluster. That sounds like a good decision, is it? Let's find out. So, a few minutes after I went on with this deployment of this big feature, I get this wonderful Slack message. I think my screen is a bit off, is it?
Yeah, I can see the all the right side.
That's so
So let me
weird. Let me
start.
just stop the sharing right there. I am sorry, you guys. I'm gonna do it. I'm gonna redo it now. Don't worry. I'm gonna solve it in like
No worries. I can't see who the user that posted on LinkedIn, but good morning, Guy, everyone in May. So good morning, everyone. And happy that you joined.
yeah, that's a good time to say good morning. Now I'm gonna go back to presenting. I bet everyone already want to know what happened, and you're gonna find out right now. Are we back with the screen sharing? Is everything okay? Yeah, I think now it's good, right? Yeah.
Yeah, perfect.
Okay. All right. So I like I said, I was 7 hours before my flight to Milan. That's when I decided to deploy this huge network change into our Kubernetes cluster. And right after I did this deployment, I got this wonderful Slack message. It said, "Hi May, our feature service is down. Our LBs returning 502 or 504 error messages, but listen, nothing has changed on our side. So could you please help us?" So I'm sitting there and I'm like, oh my God, what have I done? Okay. So I was like, okay. What I'm going to do is I'm going to fix it. I just need to delete the new network configuration. That's it. It's going to solve everything. And after I did that, I got another Slack message saying, "Hey May, so the DNS is sending me to another pod. I mean, I am trying to get to one service, but I am getting an answer from a complete other random address." Just think of it like you're trying to log into Facebook and you end up in MySpace. That's a bad, sad
Oh my
example.
God.
But that's basically what happened, right? Okay, so this is how I felt at that moment. Oh my God. And so I got another Slack message of somebody who told me, listen, why don't you join us to this group chat? Everyone is here. They want to talk about what's going on. And I see that there are, 30 participants of all seniority levels. And one of the managers just said, so when did this start to happen? And someone brave decided to say, oh, 30 minutes ago, when May deployed her change. Yeah, that's that's how I felt. I felt like, okay, I think I'm gonna need to look for a new job. What's gonna happen from now on? And I'm not gonna tell you, but I bet you want to know how did this incident end? Did I get to keep my job? Spoiler alert, I did. But another spoiler alert is that I don't have something amazing, crazy to tell you about here. I have a lot of work to share with you and a lot of small details. So brace yourselves. Before I do that, let's talk about who am I. So my name is Mey Beisaron. I am a senior platform engineer at Forder. I'm a sworn Star Wars fan. You can see all of the stuff that I've been spending my money on. And also, I am a party girl. I love to join Diablo 4 parties. Woo! And let's talk about Forder just so I can, you can get a little bit of background of where I'm working at. So Forder is the trust platform for digital commerce. We make accurate, instant assessments of trustworthiness of every step of the buying journey. And this actually helps the businesses prevent fraud and maximize their revenue and deliver superior experience for their customers. What does it mean for us? As developers, it means that we have to deal with 50 million decisions made in real time every day. And so now that you have like the numbers running in your mind, right? Let's talk about Forder's compute environment just again, so you'll get a broader picture of what I'm going to talk about. So we have AWS as our main cloud provider. We mostly run our services on EC2 instances, but over the past year, we started the migrations to EKS. And that's what we're here to talk about. We're going to talk about one of the main things that you need to take care of when you migrate your services to Kubernetes. You need to think about networking. You want to think about what are the things that are about to change because you're moving into working with this wonderful Kubernetes. And let's talk about the thing that I had to do. And that's that. That's what I needed to do. I needed to set custom ENI config for our pods.
Wow, that's crazy. Like the fact that you had to migrate like everything and networking, and we found out that you had an incident during the migration. But how do you made up like to even like going into ENI config? Like I guess there is something that caused you to go into the ENI config. So
Right. So
why do you even need that?
okay, I'm glad that you asked that question. And usually when I get these kind of questions when I do my talks, I'm so excited because then I can say, that's my next slide. And there it is. So what you see over here are the two main things that you want to take care of when you start to think about scaling your networks when you migrate to Kubernetes. And those are the main two reasons as to why we decided that we need to go with configuring that custom ENI config. What is custom ENI config? We'll talk about it. Why are these two things the reason for doing so? Let's see. So let's start with the first one, increase IP address range for pods. Now I'm going to go from, the very basic. We have the VPC, virtual private cloud. And in that VPC, we have a CIDR block. And a CIDR block in AWS is a range of IP addresses. And when you define this range, it means that you can define all of the IPs of that will be assigned to something like your EC2 instances, or if you have EKS workers, then those IP will also be assigned from this seeder block. So what you can see over here is that all instances that are running in, inside that this seeder block, they're all getting addresses randomly from this range. Now, this also means that by default, the Kubernetes pods are getting IPs also from that range. So this is what it looks like when you don't set a custom ENI config, right? You don't set a custom network interface. It means that your pods will have the same IP as your nodes, or it will just be taken from the main seeder block. Now, what is the issue with that? So far, it seems pretty rational. The problem that can rise from that is that, as you all know, or if you don't know, now you're going to know, the increasement of the pods is going to be higher than the increasement of number of instances, right? You're always or almost always going to have more pods than instances, because you can have several pods on a specific node. And this means that the amount of IP addresses that you're going to need for those pods is going to grow bigger and bigger. This can go into thousands, which means that if you only have one address range, you can run into a bit of a problem. Running out of IP addresses, that's not going to be pretty. And it's not something that I think that will happen overnight. I mean, I see, Guy, that you're laughing, but yeah, I mean, it's not something that will happen overnight, right? Because you don't immediately start having, gajillion amount of pods, but it's one of those things that you actually want to look into ahead of time and not wait until it actually happens. So how do you do that? How can you increase the IP address range for your pods? Now, I think that there are maybe there are other ways, but now I'm going to talk about how we did that with our seeder blocks in AWS. Now, when you have a primary seeder block, it means that you cannot edit or change the IP address that is defined for it. And when I say primary seeder block, it's basically the first seeder block that you create when you create your VPC. That's a small piece of information, but it's actually crucial. So you can't edit that primary seeder block. So over here, it's what we talked about. We have the instances getting their addresses all from the same IP range. Now, if we want to have different IP addresses for pods, we can do it like this. What you see over here is that we can create a secondary, an additional seeder block in that same VPC. And this means that now you can see that the pods, they have different IP addresses than the nodes that they're running on. Now, this will be done with that custom ENI config. I will show you an example in a bit, but this is generally what's going to literally happen when you apply that ENI config. Do you have any questions about that, Guy, or anybody else?
If someone got a question, you can post it on the chat, on the comments, and we will add it in here. So thank you everyone for joining, Matteo, Alessandro, and everyone.
So nice.
Yeah. So one thing that is very important, and I want to mention, is that I can't say how many people I work with, and they told me, okay, we ran out of IPs, and now we need to do these massive migrations. So it's so a common story to have it and not picking a really good seeder block. So it's interesting what we got in here.
Generally, I don't know. I think that you were referring to running out of IPs in Kubernetes, but that's definitely something that happens also if you're not running on Kubernetes. The thing is, I can definitely say that going with adding a secondary seeder block, and then if you're with Kubernetes, then, and we're going to talk about the custom ENI config, then this is one way to do it. And then if you're not running on EKS, but you're still running out of IPs, you can still use that method of adding a secondary seeder block. And what you can do there, it's a bit of work, but you can still use weighted routing. That's another thing that AWS offers. It's not easy, but it's a workaround. I mean, what else can you do? Run out of IPs? Don't do it. So yeah, so these are secondary seeder block. That's what we did. And on this, I want to say just one more thing. In order to choose the address, the IP address range for that secondary seeder block, what we needed to do was to have a deep dive into our network interfaces. We needed to check overlaps with all of the other used IPs, because you don't want to do that. You don't want to have those IP overlaps, because what's going to happen with the requests, it's a whole thing. I'm not going to go into it, but that's a thing that you need to do. So
one thing, we got a lot of questions regarding what will be the motivation to use separate seeder block for the Kubernetes cluster. So
maybe someone missed that. So I'm just going to go back quickly to say that again. So why would you use a secondary seeder block? Over here, as I said, if you have all of your instances and pods being assigned with IP addresses from one primary seeder block, it means that you might be running out of IP addresses in a bit faster when you have all of those pods getting IPs from. Wait, it's this one. 1 second. Over here, because over here what you can see is that you're always going to have more pods running on a single instance. So this can go into thousands. So it means that you can run out of IP addresses way faster, rather than if you're just having IP addresses assigned to instances. I hope this makes sense.
I think it is. Let me just add numbers so people would understand what is /24 means if you don't know what it means. So a seeder block of /24 means that you have roughly 250 IP addresses. 252 or 3, if I remember correctly.
I mean, you can go for a bigger one. You can go for /18, and then you have it by thousands, but okay.
Yeah. In this example, we go with /24. It means that if you have, 5 nodes with 15 pods on each one, that's it. You run out of IPs. So running 200 pods, 250 pods, and 5 nodes, that's it. This is the largest scale that you can get into this cluster. And this is
another thing to remember. Yeah, another thing to remember is that a lot of times it's not only EC2 instances that use this IP range to get IPs from, right? Maybe you have databases, or maybe you have other any lambdas. Anything that needs an IP will be assigned IP from this range. So it means that if you're on a limited amount of, if you're running into a problem where you have limited amount of IPs, it means that maybe you can't have an IP for your lambda function. Maybe you can't have an IP for another DB. This can be bad, and I'm saying that this problem can happen whether or not you're running on EKS. But when you're migrating to EKS, this problem will become significantly, with higher chances to actually happen. And that's why I say that if you add a secondary seeder block, it means that now you have a whole range. Over here I set with 24, but in real life what we did is we went with 18, and it means that I think we have 16,000 per seeder block. But it means that now this whole range is for pods only, and I can run wild with it. I can go for thousands of pods, and they will all be assigned IP addresses, and it will not interfere with the primary seeder block that is dedicated for load balancers, for lambdas, for DBs, etc. Now, it's not the only reason why you want to use that secondary seeder block and custom ENI config. The other reason, and this one is kind of hard, and I'm going to be honest with everyone here. I wanted to say don't tell anyone, but I'm live, so I don't know if that's the best thing to say, but I'm getting always messed up when I'm trying to think about it again and again. So if you don't understand it on the first time, don't worry. It's not that easy to understand. So first, what are network policies? So network policies in Kubernetes are rules that controls the traffic between pods and other network endpoints. That's it. Okay. So just like if you have so over here you can see the page for network policies in the Kubernetes IO docs, and what you can see over here, you see 1, 2, 3, and it says what can be, what filters you can add to those rules. So the first filter can be labels, pods labels, and the second filter can be namespaces, and the third one is IP blocks. Now keep those 3 in your mind, and don't worry, I'll remind this of you, but have those in your mind when I show you what happened to us. So let's say that we want to do not allow traffic between one pod and another pod for whatever reason, right? So then, like I said, one of the ways to do that is to do it with network policies filtered by pod labels or by a namespace. Okay, so this means that for all of the requests that are going directly inside the EKS cluster from one pod to another, this would work. But what happens when sometimes we have some requests that go from one pod inside a certain node and they go all the way to the load balancer, and then the load balancer is the one that is sending this request to the requested pod. And I'm not going to get into that, but the load balancer is using the pod IP, actual pod IP, in order to talk to it, to send the request to it. So what happens here is that you can't use labels anymore because you're out of the Kubernetes, the EKS context, right? You can't use labels. You don't know which namespace this request came from anymore. You don't know which label the pod that it came from has anymore. And this is where you can say, okay, but you also said that the third option is to use IP blocks. Correct. But remember how we said that everyone shared the same IP address space? So if I go and I add a network policy with the IP block 10.0.0.0.0, it means that it means nothing because everyone is in on that IP range. So it's not good. What we can do, remember that secondary seeder block with that custom ENI config? That's our savior, because now that the pods have different IP addresses, I can go ahead and decide what I want to do with those, with the IP blocks that I have for the load balancers. I can also use the labels for pods or namespaces for requests that are not leaving the EKS cluster and going through the load balancer. Basically, this is the solution that we went with. So now, let's go to talk about setting custom ENI config for our pods. Now, again, I want to say something about this. The title of this talk is, scaling Kubernetes networks, and it's not that I'm going to cover everything that you need to know for all of the use cases for when you want to start scaling your networks in Kubernetes, right? But those two things, right? Making sure that you have enough IPs, that's big, that's important. It's not one of the first things that will jump into your mind, and it's really crucial to look into this. And the second thing that we talked about, network policies, the reason that you need those is because back when you were running on EC2 instances, you probably, I think, used security groups to define the rules of communication. And now security groups, they are still valid for nodes, but it's not, you can do security groups for pods, but it's more limited. So I think you're going to want to have network policies, and we're gonna, so that's it. So let's talk about now the custom ENI config. What does it mean? What does it even look like? Are you all ready for it? That's it. I think like the name feels as long as this piece of text. This YAML is so short, and saying custom ENI config every time just to describe this short thing, it's crazy. I hate it. Why they needed like a more catchy name or whatever. We're not here to talk about that. So what you can see over here is actually the resource that you want to, you're going to need to define in order to have your pods be assigned with IP addresses from a different subnet than the nodes. And it's all happening here where it says subnet, and then you put the new subnet ID inside. And as you can see, you can also add the security groups that were that belonged to the nodes. You can add those here, and these will be applied also to the pods. Also, if you delete it completely, if you don't have any security groups written, it will just get all of the security groups of the node to the pods. So yeah,
how you can learn, like we talked a lot about the configuration, but how can we learn like what to configure in here? What are the options? It's
okay. So I have to give it up for AWS on this thing. They actually have a really good guide, and I kind of wanna open this up. Yeah. So custom ENI config, custom networking for pods. Oh my God, I think that I remember this page by heart now, but it's really good. And I can tell you that if you follow this step, what I liked about this guide is that it has both what you need to do if you just want to do a quick POC. I mean, quick is a big word, but if you want to just try it POC, then they describe how you can do it for testing, and then they will also specify what you want to do if you want to go for to production with that. And it was pretty easy to follow, not the best. But another thing that you want to remember is that there are some limitations on the possible IPs to assign to a secondary seeder block. Just read every single word that this document has. That's what I have to say. Okay, every single word, every single link, that sends you somewhere, go with it. Like, go look. Okay, that's what I want to say. But it's still good. Okay. So if I want to say in simple words, what I did, I was just about to start poking around the IPs of our pods in our production clusters. Yay. Yeah, that's like a weird laugh because it was fun, but not really fun. I hope you all understand.
So how does it go? Like I just apply the CRD and that's it. Everything goes automatically.
So basically, if I want to be super specific, there are two environment variables that you want to add to your cluster to enable the ENI config thing. And then you apply that the custom ENI config YAML. And there are a bit of like thingies with the ENI config YAML name and how you can have more than one per availability zone. It goes on and on. But basically, you just go with apply that YAML, and you will see that all of a sudden your pods are getting new IP addresses. Just remember to make sure that you have all of the security groups in place. And this brings me to our next part. So what I did in order to, first test and deploy this feature is that I started by just deploying it gradually on each of our clusters in each region. So I started with some dev cluster in one of the lower traffic regions that we have. And then I went in that same lower traffic region to the production cluster over there. And when I deployed and everything looked well, I was like, okay, now it's time to go to the next one, to the next dev cluster. And then it was time to go to another production cluster. And then it was time to do the main production cluster where we have a lot of, most of our traffic and a lot of nodes, pods, everything is happening in there. Now, why am I telling you all of this, really? Because this is pretty basic, right? Out of all of the things that I talked about so far, I think this is the most basic part where it's telling you that I tested, that I deployed on dev cluster before I deployed it on production cluster. Well, just keep that feeling inside of, this is so basic. Why is she telling me about this? And imagine the confidence that I had after I deployed in 4 different clusters. And now I think you understand the reason as to why on February 25th at 4 p.m., 7 hours before my flight to Milan, I decided to pull the plug and do that deployment. I think you can all agree with me. Don't agree with me. Don't do it. It's bad. Wait until you get back from Milan. But I was like, I don't know, it worked on other clusters. You remember that horrible message I got? And if you don't, here's a reminder. People started telling me that requests were going to the wrong destination, and then a lot of services were unreachable. Oh my god, my heart is racing just rethinking about this incident. Obviously I had a lot of fun. So what happened? Like I talked about all of the things that we did beforehand, and what was now you know what I deployed, and now I think that everyone can truly understand how big this change was, right? That it caused something like this to happen. So I was like, okay, I know what to do. I reached out to one of my coworkers, and we started looking into the clusters. And after digging around, we quickly realized that the target groups are not getting the right IPs of the pods, because the way it goes in our EKS cluster is that for we have a Kubernetes service, and then we're using the target group binding, and this is how the LBs have the actual IPs of the pods. So imagine that those IPs were not correct. That's it. Like the LB didn't have the right IPs of the pods. Hope it makes sense. So I was like, okay, I can find out the IPs of the right IP of each pod, and then I can manually add it to the target groups in the in the AWS console. This could work. And I mean, yeah, but we had a lot of those. So it's nice, but it's not a good idea. So my friend, she had a better idea. And she told me to relax, which I did not. But okay. She said this. She said, listen, for services that are still in migration and they're experiencing issues, let's just use our powerful migration techniques and save the day. Okay. She did not say, let's save the day. Just go with me for the story. Yeah, fine. And let's talk about what are those migration techniques that I'm talking about here. So this is generally our migration process. Obviously, there are more details into it, but we're short on time. So let's talk about the main parts that we have over here. So first of all, in order to minimize the blast radius of the migration change, all of the changes that we made in our infrastructure as code. It helped us to track the changes that we made, to make sure that everything is in its place. And then we were also able to label the apps and the LBs that are under migration. And the other thing that we invested a lot of time in is to have hybrid traffic mode, which means we wanted to be able to have some of the traffic go to the EC2 instances, and then some of the traffic go to the EKS cluster. And we put a lot of effort into getting this done. And the last thing that we had is the grace period. Right. Yeah. The grace period before cleanup, which means that we did not delete all of the resources of the EC2 instances before we were 100% sure that everything is up and running and everything is good. And that's it. So why did I tell you all of this again? Okay. So remember how we talked about the weighted traffic and the fact that we wanted to have hybrid traffic mode. And so in this very moment, it was very easy for me to use that feature and to get all of the traffic from those problematic pods, the services that were running on those pods, to get all of this traffic back to the VM, back to the EC2 instances. And then it meant that I had time to start thinking about the real solution and not something temporary. But this was important because I was able to identify through our infrastructure as code which services are currently in migration. So they still had that hybrid mode. So I was able to do that. I was also able to identify which services, because we're talking about really like tens, I think 100 something services back in that time. So it wasn't something that I can just scroll through. Just keep that in mind. Okay. Like it's all, I'm laughing and it's funny, but it's not something that is really easy or I think rational to do manually. So the fact that I was able to find those services that are under migration in our infrastructure as code, or to find all of the services that I can't do this hybrid mode for them. And then I was like, okay, these services, I can't, route the traffic back to the VMs for them. So these are the ones that I needed to go and add the IPs of those pods manually. So it's not like I got away with it completely, but at least it wasn't like 100 and something. So you got it. 3.5 happy hours later, things calmed down. And I was able to catch my flight and have the time of my life in Milan. But I also sat down to write the post-mortem because, at Forder, maybe it's going to sound like a cliche, so it's a cliche alert. We take the learning process very seriously. Like, I definitely don't want this happening to anybody else. So I sat down and I wrote everything that I could about it. And the main thing that I realized that was so difficult is all of those unknown unknowns. Like, I couldn't have known that there's going to be like some security group missing, or there's going to be like some rule missing, and it's going to only happen in that specific cluster, in that specific region, in that specific place. So, but the reason for why it did not, spiral into a complete disaster, and I was able to actually solve this thing with a matter of hours, it's because I was well prepared and I had the team supporting me at every single moment. So again, thanks to everyone, and thanks all the time. I love you guys. I love my team. So let's go to the takeaways, and then we can do some questions if anybody wants. I think that one of the important things that I want people to take from here is that you want to have eyes on your network. You want to, like, if you start poking around your networks or you're thinking about migrations, even if you're saying, oh, we think that we might, like, and that's not just for Kubernetes, right? Like, even if you think that you might run into, not enough IPs problem, you have to do this. Now, there are two ways that you can find all of the IPs used by your organization. You can either write a script for it, like I did, which took me forever because there are a lot of things to map in your network, or you can use a tool that is provided by your cloud provider, which I didn't know existed back then. Anyway, do you have any questions about that?
I think that one of the more, like, the other thing to do is to observe network, right? Because there are like very few tools that do that great. Like address manager is just to manage your IPs, and observability is a big thing in networking. So definitely, I would add to that when you manage IPs, it's a big thing. But also, if you have some other network components that you want to get observability, do not have good observability over your network if you do want to make it successful.
And a lot of times I would definitely go with like buy versus build in-house, because by the end of the day, building this script, it took me some time, and I don't think it's as good or thorough as using a tool that somebody sells. Always, it depends on your use case and blah blah blah, but still, that's my opinion on that. Another thing, I think that I said it a lot of times, but here is the last time I'm going to say it. Be sure, if you're talking about scaling, first thing they want to make sure that you have enough IP address range for your pods. There are a lot of pods. It's going to increase rapidly. those IP are going to be taken very, very fast. So you can either, do it in advance when you're just starting out and you're just assigning those seeder blocks if you're just created the VPC. But if you're working on an existing network, you might want to increase it by using a custom ENI config and adding secondary seeder blocks.
I think one of the main things to say in here is that there is no easy way to do the migration. So if you do not reserve good enough rangers or enough addresses, you would always need to go through what Mey have gone through. So there's no escape from that, and that's the biggest thing in here.
Yeah, and also be sure that when you decide on which IP address you're going to use for those seeder blocks, be sure to check for overlaps with the rest of your network. Be sure to check that you're not maybe using IP addresses that are publicly available, that are publicly routable. I mean, it's not something that, at least from what I know, AWS enforces. So if you use some IP that maybe, I don't know, Facebook uses, then you're going to run into a big problem there. So be sure to check the IPs that you decide to use for your seeder blocks. And the last thing that I want to say is I think that it's a good practice to work on network policies. Look, just because we don't think anyone is going to go into our network, it does not mean that it's true. I mean, things happen. So you want to be prepared, and you don't want to be like afterwards, oh, we should have that, right? You want to be prepared for this moment where somebody was smart enough, whatever, and got somehow got the capability to be in your network. So at least let's prevent this person from being able to navigate through all of your services. And it's not just that. That's also a good practice in order to understand what's going on between teams, what's going on between namespaces. And it's not that hard to set up. Network policies is pretty simple to do. And remember, security groups, it's not always enough when it comes to Kubernetes. With that, I will say thank you. I've been talking a lot.
No, it's great. We do have a few questions from the audience, so I will just share them so people know. But
yes,
thank you for sharing your story somehow. So we have it's not that one. So Chaya asked what is the equivalent in OpenShift for ENI config? I will take this one. So it really depends on the CNI that you're using. I know that OpenShift can be integrated with multiple network interfaces and overlay networks. So I guess they have something equivalent depending on the CNI you're using, but I don't know exactly what you have when you use OpenShift out of the box. And another question by Ophir: do you have any recommended Grafana dashboards for tracking, monitoring the networking IPAM utilization?
That's a painful point right there, because I am I'm going through a lot of community Grafana dashboards at the moment for different things in Kubernetes, and while a lot of them are pretty helpful, I didn't find one that goes deep enough for that. And I can say that from my understanding, I think that the address manager from AWS, I think it's pretty nice. I checked it out, but I do think that it can get pretty expensive. So my answer is not that fun. But if I'll find something, I'll post it everywhere because it will be amazing for me. So yeah.
Cool. So Mey, thank you very much for coming in here and sharing your story. I think I learned a lot during the session about networking, scaling network, and the problem that you had. So I need to thank you personally. And it was amazing a walkthrough around the story, all the things that you need to think, plan, and always and how to execute it well, which is the hardest part. So
I mean, I'll be happy to answer more questions if anybody has, maybe like either on my Twitter account or my LinkedIn. Somehow I got into loving those networks thingies. Now I'm working on another big project in that area. So it's like I wake up into a pool of IPs every day. This sounds horrible, but that's okay. That's my life now.
So if you have other networking question, you can follow May on X or LinkedIn, and as May suggested, you
Yeah,
offer, you can ask and text her there. Thank you everyone for joining. Thank you for being so active and writing us questions. It really makes us happy to see that you are here with us and asking questions. It really feels everything in here.
totally.
Um,
Yeah.
and every week we are doing this live sessions. This is the last session for this queue, and in the upcoming week or two we will post the agenda for Q3, which I cannot share a lot, but there are a lot of amazing sessions there. That's it. Thank you very much. See you next time next week. Bye
Bye.
everyone.